I want to make a quick comment about the recording coming up here. You'll see when I get to a certain point, I don't know what I was thinking, but I look at the circuit and I say, and I might say this more than once, I don't know how many times, but I'm looking at this circuit right here, and I make a statement about some things that are in parallel when they are not. So I just want to clarify that before you see me say it, so you know that I'm wrong when I say that. And then I see what I did and I go back and fix it. But just want to point this out, that when you see me say this, ignore that part. So I have redrawn the this part of the circuit right here, and I redrew the inductor as a short circuit and the capacitor as an open circuit. And for some reason I said that the capacitor was in parallel with the 5 ohm voltage source. The capacitor is not in parallel with the 5 ohm voltage source. The capacitor is in parallel with this branch right here. Now this resistor is not doing anything, so it's not a problem, but the one side of this capacitor is at this voltage, which is at the voltage of the bottom branch, and the other side of the capacitor is at this voltage, the voltage of the top branch. And so when I find my voltage, I need to find the voltage at the top minus the voltage at the bottom, which I end up making ground. So at some point I find the voltage across this resistor, which I do need, but then I say, well, it's in parallel with this, and so that's the same voltage. Well, it is absolutely not, so just heads up on that. So this problem is very similar to one you have in your homework. I think you were assigned 528. This is 529. You're supposed to determine the voltages across C1 and C2 and the currents through L1 and L2 under DC conditions. So what I'm going to do is I'm going to redraw the circuit, and I'm going to replace the capacitors with open circuits, and I'm going to replace the inductors with short circuits because that's how they act under DC conditions, and then we'll analyze it from there. So on the left hand side we have L1 as a short circuit, we have C1 as an open circuit, and then L2 is a short circuit, and C2 is an open circuit. So if we look at the current at the circuit as drawn here, then we can see that as after enough time, we really have only current flowing through this branch right here in this direction, so going clockwise, because of the open circuit right here and right here. There's no current flowing through those branches. So we automatically know if there's no current flowing through that branch, then we can say the current through L1 is 0 amps. There's no current through L1. Now, there's no current through C1 and C2. That does not mean there's no voltage. You can very much have a voltage difference when there's no current. So we will have to find that. Now, since the current that's flowing in what is left here is just one loop, that's all series. And so we can just use Ohm's law to find the current. So the equivalent, all of the resistors are in series, and so that's 5 plus 6 plus 4, that's 15 ohms, and it's 30 volts. So V equals IR. So 30 equals I times 15, or I equals 2 amps. that's the current flowing through this branch, and as such, it is the current flowing through L2. So L2 is 2 amps. That's the current. Now we need to find the voltage across our two capacitors. Well, the way you find the voltage across an open circuit is you find something it's in parallel with. So let's start with C2, and we see that C2 is in parallel with this 6 ohm resistor right here. And so if I can find the voltage across that 6 ohm resistor, then I will know the voltage across C2. So the voltage across the 6 ohm resistor, that's V equals IR. So our current we just found was 2 amps, the resistance is 6, so our voltage is 12 volts. And so our voltage across C2, VC2, is 12 volts. And C1 is in parallel with the 5 ohm resistor. So I can do the same thing for that. So V equals IR. So I'm finding the current through the 5 ohm resistor right here, because that 5 ohm resistor is in parallel with C1. Notice this 10 ohm resistor, it's not doing anything because there's no current flowing through it. A resistor with no current flowing through it is not doing anything. It's not changing anything. So the voltage through the 5 ohm resistor, V equals 2 times 2 amps times 5 ohms. V equals 10 volts. So that is the voltage on the C1 is also 10 volts. So VC1 is 10 volts. Now the current, if we look at what side, so it's in parallel. It is not. It is not. It is not. It's not in parallel. I don't know what I was thinking. Okay. Why is it not in parallel? It's not in parallel because there's this voltage source in between. Because I was just about to show you something. It's like, well, wait a minute. Okay, so it's in parallel with the combination of the voltage source and the resistor. So we need to figure out what the whole voltage difference is. So let's make this ground. And then on the other side of the voltage source, we have 30 volts right here. And then as the current goes through this resistor, it loses 10 volts. This is so wrong. So wrong. It loses 10 volts. And so after it's lost 10 volts, the voltage up here is 20 volts. And so the voltage across this branch is 20 volts, not 10 volts. So VC1 is 20 volts. And then what I was going to show when I realized my foolish mistake here is to show you what side is positive and what side is negative. So if we look at this branch that we just figured out right here, the bottom is 0, the top is 20. And so the top up here is at 20 volts, the bottom's at 0 volts. So if I want to call C1 20, or the voltage on C1, it's not C1, it's the voltage across C1. VC1. Then I can put the plus on top and the minus here. Similarly, across the 6 ohm resistor, the current is flowing to the right. And so that means that it's positive on the left-hand side and negative on the right-hand side, because current flows from higher voltage to lower voltage. So if I call C2, the voltage on C2 12 volts, then that means I'm calling that side positive and that side negative.